Hey, welcome back to Brightside Science. Today, we're diving into one of the most fascinating climate stories on Earth. Let's get started. From destructive floods to prolonged droughts, the Earth's climate is constantly shifting. But what if I told you that much of this chaos is driven by a single, powerful climate phenomenon that spans the Pacific Ocean? It's called ENSO, the El Niño-Southern Oscillation. In this video, we'll break down ENSO, how it works, and what causes its different phases: El Niño, La Niña, and the Southern Oscillation, as well as the Walker circulation. We'll also explain how these climate shifts impact weather globally. Let's get started. ENSO stands for El Niño-Southern Oscillation, and it's a naturally occurring climate pattern that repeats every few years. It has two main phases, El Niño and La Niña. These phases are driven by changes in the temperature of the Pacific Ocean and the winds that blow across it. ENSO occurs primarily in the tropical Pacific Ocean, along the equator, where it receives great amount of sun rays, which warms the ocean. The key region affected stretches from the western Pacific, near Indonesia and Australia, across to the eastern Pacific, near the coasts of South America, particularly Peru and Ecuador. Think of ENSO as a seesaw. On one side you have El Niño, which leads to warmer ocean waters. On the other side, there's La Niña, which causes cooler ocean temperatures. The balance between these phases can dramatically change weather patterns around the world. To understand how ENSO occurs, we will need to break down it into three phases, even though there is only two phases. Let's take the first phase as normal phase. Actually, there is no such phase called normal phase. It is added just to make the topic easy to understand. In this phase, the central Pacific Ocean is warm. Now let's bring in the trade winds. They are strong winds that blows in tropical region from east to west, so it pushes the warm water towards Asia that makes the western Pacific Ocean warm. When warm air rises up into the atmosphere, where it cools and condenses to form clouds and eventually rain. The warm air then travels to the eastern Pacific region. As the air moves eastward at high altitude, it cools down, losing much of its moisture content. This process causes the air to become progressively drier as it moves over the cooler waters of the eastern Pacific, contributing to the dry climate and deserts seen along the western coast of South America. This process of rising warm water in the western Pacific and cooling and sinking in the eastern Pacific continues, and this atmospheric circulation pattern is known as Walker circulation. Let's go to the next phase, El Niño. During an El Niño event, the sea surface temperatures in the central and eastern Pacific get much warmer than usual. Normally, trade winds, strong winds that blow from east to west, push warm water toward Asia. But during El Niño, these winds weaken. This means warm water that would usually stay near Asia flows back toward the Americas. That means the warm ocean water is replacing the cold ocean water that exists in the central and eastern Pacific. This major shift changes the way the air moves above the ocean, causing big changes in weather. Normally, the Walker circulation drives rising air, cloud formation, and rainfall in the western Pacific, near Indonesia, Southeast Asia, and northern Australia. During El Niño, as warm water spreads eastward, the main area of convection shifts toward the central and eastern Pacific. This brings increased rainfall and storm activity to the central and eastern Pacific, including places like the western coast of South America, which are usually dry. El Niño often causes heavy rains and flooding in South America, particularly in places like Peru and Ecuador. Meanwhile, countries in Southeast Asia, like Indonesia and parts of Australia, often face droughts because the usual rainfall shifts away from them. Now, let's look at La Niña. It's basically the opposite of El Niño. This phase is similar to the normal phase, which we have discussed earlier. During La Niña, the trade winds become even stronger than usual. They push warm water further west, allowing colder water from deep in the ocean to rise up along the coast of South America. La Niña typically leads to colder ocean temperatures in the eastern Pacific and warmer conditions in the western Pacific. As a result, countries like Indonesia and Australia experience more rain and storms, while the Western Americas tend to be drier. La Niña can bring an increase in Atlantic hurricanes, wetter weather in Southeast Asia, and colder winters in North America. Each phase of ENSO has a different set of weather effects depending on where you live. So, what connects El Niño and La Niña to the atmosphere? That's where the Southern Oscillation comes in. The Southern Oscillation refers to the changes in atmospheric pressure over the Pacific Ocean. During El Niño, the atmospheric pressure over the eastern Pacific drops, while it rises in the western Pacific. This is what weakens the trade winds. During La Niña, the opposite happens. Pressure rises in the east and drops in the west, making the trade winds stronger. These shifts in wind patterns are part of a larger system called the Walker circulation, which moves warm, moist air from the Pacific towards Asia. In normal years, this circulation works like a conveyor belt, bringing rain to Asia and keeping the Americas drier. When El Niño hits, this circulation weakens, pushing the rain away from Asia and toward the Americas. During La Niña, the circulation speeds up, bringing even more moisture to Asia, and making the Americas even drier. So why does ENSO matter? Because these changes in the Pacific affect weather across the entire globe. El Niño and La Niña can disrupt agriculture, cause water shortages, and lead to extreme weather like floods, droughts, and hurricanes. In South America, El Niño can devastate crops with heavy rains, while Southeast Asia can face severe droughts. In North America, El Niño can bring stronger winter storms, while La Niña increases the risk of hurricanes in the Atlantic. Today, scientists closely monitor ENSO using satellites, ocean buoys, and weather models. They track changes in sea surface temperatures and wind patterns, providing early warnings when El Niño or La Niña is developing. By predicting these events, governments and communities can prepare for the impacts on agriculture, water supply, and disaster response, potentially saving lives and reducing economic damage. Understanding ENSO helps us make sense of why the weather can be so unpredictable. From rising sea temperatures to shifts in wind patterns, ENSO influences the world's climate in powerful ways. And the more we know about it, the better we can prepare for the challenges it brings. Thank you for watching. If you learned something new today, be sure to like, share, and subscribe to stay informed about the world's most important climate phenomena.